geometry. Hopefully your track meet fun began. This can really extend into some big concepts, especially the last section 12.5, but it's still, this is just an intro. And before we start, we're going to do a little warm-up here. We have the combination, and if you recall, you can do the combination using Pascal's triangle. I'm trying to figure out where did I have that. Here it is. Go to row 6, 0, 1, 2. The answer should be 15, but I just messed this up. Now let's go ahead. So here we go. That is the same as 6 factorial, okay, we can't really see this, over 6 minus 2 factorial times 2 factorial. Remember, the difference between a combination and a permutation is the combination we're dividing out the additional amount of ways that subset could be ordered, because order doesn't matter here. So 6 times 5 times 4 times 3 times 2 times 1 over 6 minus 2 is 4 times 3 times 2 times 1. And then 2 factorial is 2 times 1. And if you'll notice, these will cancel. 6 times 5 is 30, divided by 2 is 15. Alright, what's the probability that 2 flipped coins show heads? I wish I left more space here, but let's do a tree diagram. So our first coin is a head, the second one is a tail. And then the second coin would be a heads or tails, and then heads or tails. So what's the probability that we have two heads? It's the only way you can get 2 heads out of 1, 2, 3, 4. So the probability of 2 heads is equal to 1 out of 4. So you can also do the multiplication rule for this. Think about it. If you want the probability of getting a heads out of a coin flip, you have 1 out of 2. What's the probability of getting heads again? 1 out of 2. You get 1/4. Okay, so using the multiplication rule. Wow, why does this not come in? Oh, I have the light on above me. Wonder who did that. Alright, so next one. A card is drawn from a standard deck of 52 cards. Hopefully that's better. And hopefully I remember to bring some cards to school so we can examine them, because I know a lot of students don't play with cards anymore. What's the probability of a red card? There are 13 red cards, and so you get, oh sorry, not 13, 26 red cards out of 52, and that will reduce to 1/2. And how about a jack? There are 4 jacks, one of each suit. So you have 4 out of 52. That reduces to 1 out of 13. Alright, so here we go. When you consider all outcomes of either 2 events, A and B, you form a union of A. Sorry, I don't want and there. I want A or. Sorry. I know that sounded weird. You want an or there. When you consider only the outcomes shared by both A and B, okay, so now this is where we have an and, you form an intersection with and, okay? So intersection is the word and, a union is the word or. Nice. The union or intersection of 2 events is called a compound event. So if I want the union of A or B, it would be everything together. That's why both circles are shaded. These are called Venn diagrams. If I want the intersection of A and B, it's just what they have in common, right there. But if they have nothing in common, the intersection of A and B would be empty. This is called disjoint or mutually exclusive. I like to abbreviate that ME. Okay? So, to find A or B, you must consider what outcomes, if any, are in the intersection of A and of B. So 2 events are overlapping if they have 1 or more outcomes in common. two events are disjoint or mutually exclusive if they have nothing in common. Okay, so that's what I was saying right there. So for instance, if they're disjoint, okay, now I know this is kind of blurry, but your copy is not. I printed off my printer. This is what your copy will look like. So it's, well, not colored, but. All right, so the disjoint, if here's A, here's B, they're just separate, you add them up. You simply add them up. But if there's overlapping, you're going to take A and B and then subtract what they have in common. Let's make that a little better. Okay, so here's the formula in general. The probability of A or B, you're going to be adding them up. Probability A plus probability B. Subtract what they have in common. So if there's nothing in common, you don't have to subtract that part. So that's why they have just these two. So let's demonstrate. Okay, so here we go. A card is randomly selected from a standard deck of 52 cards. Find the following probabilities. What's the probability of a 6 or a king? Well, that cannot happen at the same time. You have 6 cards, you have king cards. So the probability of getting a 6 is 4 out of 52. And then the probability of getting a king is also 4 out of 52. Add them up, 8 out of 52, reduce, 2/13. We didn't have to subtract anything because it's mutually exclusive. You can't get a king or a 6 at the same time. So, and one thing I want to emphasize is the word or, you'll be adding. Now, what if something can happen at the same time? They overlap. That would be this case. Find the probability of a 7. Well, you have 4 out of 52 plus a club. Remember, there are 13 clubs out of 52. But the problem is the 7 of clubs is in this grouping, and the 7 of clubs is also in that grouping. We can't count that card twice, so we're going to subtract it away. So 4 plus 13 is 17, minus 1 is 16. 16 out of 52. Divide both by 4, you get 4/13. How about this one? Probability of a 9 or a red. Well, we have 4 9s. Red cards, we have 26. Problem is, there's a red heart and a red diamond. A 9 of hearts and a 9 of diamond. They're both red. So we're counting 2 cards here, the 9 of diamonds and the 9 of hearts. We're also counting those 2 cards here. You can't count them twice. So I'm going to subtract it away. So 26 plus 4 is 30. Subtract 2, you get 28 out of 52. Divide top and bottom by 4. 7 out of 13. So far, so good? All right. So we have 2 dice. This would be a 1-1, 2-1, 3-1, 4-1. I don't know if you see the pattern. But I like to kind of break off the middle right here because this would be a sum of 7. 7, 7, 7, 7, 7. And you're going to notice there's a pattern. Right here would be the sum of 6, 6, 6, 6, 6, sum of 5, 5, 5, 5, etc. It comes in handy when we're solving these problems. Find the probability that the sum total is equal to 4. So that would be here. I have 1, 2, 3. That's 3 out of 36, which is equal to 1/12. How about the sum total is less than 7? So this is why I like to branch off 7. So we'll count less than. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 15 out of 36. Divide top and bottom by 3. You're going to get 5/12. The sum is greater than 9. Okay. So here are the 9s. So 1, 2, 3, 4, 5, 6. 6 out of 36, which is 1/6. And then the sum is, okay, here's our compound event. Finally give it to you. I just wanted you to practice with the dice. The sum is total is even or greater than 9. So evens. All right, so that'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Well, how about that? Half of them or even half of them or not. So 18 out of 36, greater than 9. All right, so that would be 1, 2, 3, 4, 5, 6. Oh, we knew that from right here. I picked it on purpose. Problem is, do I have some that are greater than 9 and even? Well, let's see here. The greater than 9s that are even, let's see here, would be 1, 2, 3, 4. So I'm going to, because that's counted twice, I'm going to take 4 out of the 36 away. All right, so 20 out of 36, divide the top and bottom by 4, you get 5/9. What do you think? All right, complementary event. Complementary event means not. Like, for instance, if we had a probability, well, today we had a probability it was supposed to rain 80%. So the probability that's not going to rain would be 20%. So, for instance, if this is event A, this is the probability it's going to rain. Probability not going to rain is right here. So I have to be surprised that Blaze had baseball today, JD did not, and I'm sure you had track. So, complementary. The complement of A denoted A prime, or a line above the A, or an A with a little C right there, consists of all outcomes in which the event A does not occur. One thing I want you to know, the probability of the event plus the probability of it not happening will equal 1. So if I solve for the probability of the event, it's going to equal 1 minus the probability of it not happening, just by subtracting that to the other side. It may be easier to find the probability of not happening and then use the above equation to find something happening. For instance, what if I said, what's the probability of rolling a set of dice that the sum is less than or equal to 9? Well, my 9s are right here, so I have to add all those up and get your answer. But it might be easier to say this is the same as 1 minus the probability of the sum greater than 9, okay? Because if I take 9 and below and greater than 9, that would be all of them, right? So if I just find this one, I'll have this answer. Well, I conveniently did this problem right there. So 36 out of 36 minus 6 out of 36, because I did it right here. 36 minus 6 is 30, which is equal to, divide the top and bottom by 6, you get 5/6. Of course, I could have used the 1/6. Could have taken 6/6 minus 1/6 to get my answer. Nifty, huh? So sometimes the complement is easier. That's going to be a big, big topic in high school. All right, here we go. Use the following, or use the diagram for the set of die again to find the probability that the sum is not 5. Well, so that means it might be easier to do 1 minus the probability that the sum is equal to 5. So we have 36 out of 36 minus, okay, let me pull up the dice again. You know what, let me pull up the dice for my other sheet. It's just so much nicer. Okay, so we have to find the sum of 5. Okay, the sum of 5, here's 1, 2, 3, 4 of them. Okay, so subtract. You're going to get 32 out of 36. Divide the top and bottom by 4, you get 8/9. So here it was easier to do the complement. How about the probability that the sum is less than or equal to 10? Well, it's the same as doing 1 minus the probability that the sum is greater than 10. All right, so what's greater than 10? Okay, here are the 10s. So we have 1, 2, 3. So 36 out of 36 is 1 minus 3 out of 36. I was just getting a common denominator. Is 33 out of 36. Divide the top and bottom by 3. You get 11/12. What do you think of that? Okay, so now the one thing I want to do with this last one was our equation from the first page right here. Okay, so I'm going to rewrite this equation over here on the side. The probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so sometimes it's going to be easier to use the equation to find this. All right, here we go. Of 100 students surveyed, 92 own an iPad or a computer. So I'm going to say iPad or computer equals 92. Also, 65 own iPads. 82 own computers. What is the probability that a randomly selected student owns both an iPad and a computer? Okay, so let's think about what we have. The probability of iPad or computer is 92. Oh, that's right here. Well, it's 92 out of 100, but let's just use the solid numbers. The probability of the iPad is 65. The probability of computer is 82. The probability of iPad and computer, we don't know. So I'm just going to call this X. So let's add these two up. 92 is equal to 147 minus X. If I subtract 147 on both sides, naturally I ran out of space. I'll have negative 55 is equal to negative X. So that means X is equal to 55. And that's what I was looking for. What do you think? Pretty nifty, huh? Didn't see that coming. All right. Well, here's our homework assignment. This one, maybe. We'll see. And all of those standards. So we're doing a lot in one section. And again, these are just like an intro stuff. And get you prepared for high school. So have a nice Easter break. And Alex, good luck on that pilgrimage. It might rain tomorrow.